Hi, this is Ryan Bell, and uh, today I'm just gonna give a short demo of PCA, or Principal Component Analysis, and I'm gonna show you where to find some really interesting code that you can apply to images or any data set. So let's do that. I'll show you how to find it. Since you can just Google PCA kernel and pre-image MATLAB, and there it is, the first one. And you can verify you got the right one by Quan Wang. Download it. I already have it downloaded, so once you do that, unzip it and put it in the right directory, and you will have, let's see, so you'll have basically this. This is a PDF that describes what sorry. This is a PDF that describes what this group has done and some math behind it and their experiments and results, and here's the code. I've added some extra stuff, so I believe there's like 6 things in here, 6 MATLAB files that you would have or in here, or MATLAB data. It's mixed. So let's go to MATLAB, and I'm going to show you how to use it. So basically you want to, it comes with data, but that's just a bunch of points. So if you want to see it applied to an image, you have to do some extra stuff. So I already downloaded an image, and that's the dog 2D mat. So I'll go through what I did to get that. So you download the image, put it in the right directory, and here, for example, dog equals IamRead grayscale, the grayscale dog image that I downloaded. So I do that, and you'll notice up on the right here that it's 3-dimensional uint. So we need to convert that to double so that'll work. So you do that, dog equals IM2 double of dog, and then so now it's a double, you'll notice on the top right of the MATLAB window. And then once you do that, there's only one more thing you need to do. You need to get rid of the 3rd dimension, because this code takes 2-dimensional plot. So you know, for the x and the y values of the image. So you do dog, and then you put the parentheses with colon, comma, in this case 2, and that'll get rid of the 3rd dimension for you. So if you look up in the top right, you'll see that dog 2D it cuts out that by 3 at the end there. It cuts that out, so it's 2-dimensional once I do that. So once you do that, you can right click over here and just save it, and that's why in here I had the dog 2D. And then you want to go into the code. You can just go into the demo, and you can just do Control F or Command F for the Mac, and you find data and replace it with dog 2D, or whatever you called your data set, so to say. So once you do that, you're ready to go. So you run it, and there's some results right there. And I should mention that that this code has it has the standard PCA and a kernel PCA, or a Gaussian kernel as they call it, PCA implementation. And so The difference between those is that the standard PCA only accepts linear dimensionality, and so once you go beyond that, it becomes invalid. And so the kernel PCA allows you to generalize the standard PCA formulas, or the standard analysis, the component analysis. So you've got that, and the different colored points, the blue stars and the red circles, those signify different classes. So you can see how they're getting separated into separate classes, these points. And now, let's see. So let me show you a little bit of the PDF. I believe another one of my group members was going to be talking about PCA, so I won't bore you by reiterating over all that. So one of them should have that covered. But this PDF is good to read through because it's nice to have alongside the code and the results, because you could really see, what they were thinking and how the code came about. And it talks about the advantages of like the regular PCA versus the kernel PCA. Like by looking through this, that's one thing that I learned was how the kernel PCA is the generalized version of the traditional PCA. So it's got that, and it does go in depth with the math. So if you want to look into that, it'll have a lot of explanation or formulas that you can look at and see where these come from. And so that's pretty much it. Thanks.